on right now. So yeah, I'm on YouTube now. Then okay, so I just wanted to share a couple things with you. So I'm gonna make the test or assignment or whatever you want to call it. I'm gonna have it available right at the end of class. So that's gonna be the thing that I'm gonna do right at like 2:20. So in about an hour's time, I'm gonna put the test on the website. Now there's a couple of things that we just have to keep in mind just about honesty and kind of just sort of understanding that we're in a very unique situation. So we're just going to be good humans and be honest with each other and help each other out when needed and that kind of thing. So there's a couple of things that you can do for yourself. Because you have to take care of yourself in these situations. So if you're stuck and if there's a question that you're like completely blanking on, you can reach out to me. So even though this is a test, just because of the nature of our situation, honestly, I feel like I've tried pretty hard to help you out with these topics, but it's quite possible that even so you might have just struggled with them enough that that you don't get it, and that's okay. So I guess what I'm trying to say is that what you can do to help yourself is to ask me for some help. You can also ask some of your peers for help. So that's another thing that you can do for other people is help each other out. So even though we don't really do this on tests, in this case, if you'd like to help out your friend, I'm okay with that. But what I would really like you to do, if you are gonna sort of collaborate in any way, I'd like you just to let me know how you collaborated. It doesn't have to be super in depth, but if you could just say, like, let's say you're working on question 2 over here, and then you solve it, then you could say, so here I worked with Isaac Newton. He helped me out big time on this question, right? So you could just tell me a little bit who you worked with. And conversely, like if you just asked someone for help, you're like, okay, look, Leibniz, I don't know where to start. Then you could say, I asked Leibniz, and I always forget how to spell his name. And a TZ, yeah, EI, whatever. So I asked Leibniz for help. And then similarly, if you're Leibniz, then you could say, okay, I helped Mr. Bennett with this question. So just so I can see both sides of it. So just keep a record of who you're helping and who you helped with, and if you collaborate, if it's like a genuine collaboration, like if the two of you are just like, okay, what do we have to do? I tried this. What did you try? And it's kind of a back and forth. Then just tell me that you collaborated. And if it's a big group thing, I'm just gonna ask that we don't have a big group discussion. Let's try to keep it to like smaller groups. Because the thing about with a big group situation, and I think that working in big groups is important. Like we're doing it right now, and that's like obvious. This is obviously like an example of how it is important to be able to work in big groups. But the problem with working in a big group, like if we have, like I know that we have this Discord, but as far as I know, there's another Discord that you guys have, and my only concern is just that it would be just too easy just to kind of sit back and just let everyone else do all of the work. And then kind of once we all sort of figure it out, then just be like, okay, yeah, no, I'll just copy down the answer, So when it's in smaller groups, like groups of 2 or 3, then I think it's just a little bit easier to just, make sure that everyone is like really, truly collaborating. Did you have something to say? Okay, so the question was, can we compare answers? if it's in a small group, I'm okay with comparing solutions. But yeah, like what I would really be upset about is if someone was on like a private Discord and was just announcing their solutions in such a way that other people could just copy them down. And I recognize that there's no way of me enforcing this. Like I'm just asking you politely to please not do that. And there's no way that I can stop you from doing that. And I'm aware of that. But I'm just hoping that we can kind of understand the situation that we're in and try to understand that, I've been working really hard to make this successful. And if you could do the same and kind of meet me halfway, it would go a long way. So yeah, if you want to, compare solutions with your friend, I think that's okay, as long as it's in a small group, like a group of 2 or 3, and that you record on your answer key how you actually collaborated, and if you compared solutions, or if you gave this person a kind of a head start or like a hint or something like that, or if you received a hint from someone, just keeping track of that. Just so I can see like how much collaboration is being done and that kind of thing. So I kind of feel like if there's a record of it, then hopefully that'll kind of just remind us not to just have like a big group chat where we're just kind of listing, like having one person do the brunt of the work and then everyone else just sort of copies the question, right? So so that's my goal. Go on. So yeah, okay. So the question was, how is this going to work, like logistically? Like how are we going to actually hand it in and everything? So the way this is going to work is, I started fiddling around with CrowdMark earlier this week. I invited my grade 10 class to use CrowdMark, and I kind of use them as my guinea pigs. So I've kind of been like asking each one of my classes to do like little sort of guinea pig style stuff. Like I think that I got you guys to test out these Discord videos and stuff, and I got my grade 11 class to sort of polish the Discord, and I got my grade 9s. I forget what I got them to do. Maybe I should get them to do some guinea pig stuff. But my grade 10s, I use them as sort of a test run for CrowdMark. And I think CrowdMark works really well in some situations, but I just don't think it's going to work well for me. And also the students that I tried it out with, they like almost every single one of them complained about how complicated it was. And that probably has a lot to do with the fact that it's my first time using it, so I couldn't really provide like, good instruction on how to use it effectively. But I think it's just going to be easier for everyone if we don't use CrowdMark. I'm going to use a different program. Do you have a suggestion? Yep. Yeah. Mm-hmm. You read my mind. That's exactly what I was planning on doing. So So I've been setting up Google Classroom the past 24 hours or so. I haven't started the AP Calc classroom yet. So I've got a classroom for all of my classes except you guys so far. I'll add you shortly. So I'll give you the test in the meantime, so you don't have to wait for me to set up this Google Classroom, so you can actually get started with it. And the way it'll work is for each question, I'm gonna have a question on a Google form, and that'll be your assignment. And then at the end of the Google form, you can have like an upload section. So what I'd like you to do is photograph your work and just like a picture of each page. So for the most part, most of this is multiple choice. So basically, the way the marking scheme is going to work is that if you get the just in the interest of making everyone's life easier, if you get the multiple choice question right, I'm just going to give you full marks. I'm not going to mess around with like, yeah, digging through your work. But there are quite a few long answer questions as well, because I've kind of combined like an in-class test with a take-home test. So it's kind of just like one big long test. So the last, I don't know, what is it? Got it right here. I guess it doesn't really matter. The last, 5 or 6 questions are, okay, hold on a sec. 1, 2, 3. I think it's 4 questions. The last 4 questions. Oh, maybe it's more than that. Anyways, the last half a dozen questions or so are long answer. In which case, I am going to have to sort of dig through your work. So there's a few. Go on. I would much prefer scan, but I know that not everyone has the technology to do that. I'm going to put together a little tutorial on my website on how to use your phone as a scanner, because it'll just make my life a lot easier if I have a PDF instead of a bunch of JPEGs to filter through. Because the nice thing about a PDF is that if you're sending me like 5 pages of work, then that's just one file and I can just scroll through it instead of opening a JPEG and marking it up in Photoshop or something silly like that. It'll just be much easier if it's a PDF. So I'd much prefer a PDF, but I can't expect everyone to use the software that I want to turn it into a PDF. So if you already know how to do that, then please just give me a PDF. It's typically much easier to read as well, because a lot of the software will sort of increase the contrast so that it's easy to read. Whereas a photo, like if you have bad lighting and stuff, it's almost impossible to read. So I'll put a note about kind of what I'm expecting. And yeah, it looks like, okay, so there's about 10 questions. No, 16 to 19. Okay, so there's about 5 questions. Wait, how is there more than 160? Oh no, okay. There's 8 questions. I guess that I numbered them wrong. Whatever. Yeah, there's some questions that are long answers, so those are the ones that I am going to have to mark up. Let's see. I think that there's like A, B, and C every once in a while. I don't think that we ever go up to I. Let's see. One of them goes to B. Oh, one of them goes to E. But they're all just little questions. Oh, you can see my screen right now? Oh, okay. I thought that you could only see my OBS window. I guess I just showed you the test. Oops. Here, I'll close this now. That's weird. Monday. Till Monday. Yeah. Yeah. I'm going to post it as a PDF, and then okay, so what I'll do is I'm going to post it as a PDF on my website, but then the way you will like answer it, like when you hand it in, it will be through a Google form. So that way I can just give you the PDF, and then I'll figure out how the entry will work, and then you can enter it in on Monday. Yeah, I mean, provided I have the Google form set up for you. Yeah. Oops. That is not what I wanted to do. Shoot. Okay. Okay, give me a second just to get OBS Studio working here, and then we'll actually get started. OBS Studio doesn't have a undo button. Scale to window. Okay, here we go. That's kind of annoying, eh? Okay, so I think that's good, and then I'll do this. I think I might have to stop my stream for a second on Discord. Okay, here we go. This coming Monday, so you have the weekend. Oh, really? Yikes. Well, I mean, that'll give you something to do over the break, eh? Do you? Okay, you know what? I'm just gonna do this. Okay, I'm just gonna do this, and then you guys can see that, okay? Really? Oh, okay. Well, it's like, okay, that's another bad one. Yeah. Okay. Okay, I might just do my whole screen. Okay, and then I'll do, can you guys see that okay? Like, it's my whole screen now. Is that better? Okay. Yeah, like my grade 9 class, I had, like I think I told you, remember my microphone wasn't working? I did 2 whole classes. You can see the test right now? No, this isn't the test. These are exercises. Is this what you could see the whole time? Oh, yeah, no, because I had other stuff on my computer screen. This is just my iPad. I just copied these questions. See, these are my notes from yesterday, remember? I just copied these. These are just exercises. This is not the test. Okay, because I was freaking out. I thought that I had set it up so you could only see my iPad screen, and that turns out that is true. I did. Okay, because I opened up the test on my other computer screen. Okay. Anyway, so I thought what we could do is just do a couple sort of review questions. I put this exercise set on the website. There's quite a few questions on here. But the thing is, there's solutions, or not solutions, but there's answers. So if you would like to sort of practice these, there are like I think that this is kind of nice to have to just sort of like, you know, test your skills like while you're also working on the test. And I know that you guys probably have lots and lots and lots of work to do, so you might not, like in actual practice, you might not actually do that, but at least the option is there. So if you'd like to sort of try some of these out for yourself, and then you know, check your answers against the answer key, you can do that. So I thought maybe I could just do a couple of these, get us warmed up, and then we could spend the rest of the period like just having you guys work on these. And by the way, these are available on the website right here. It's under Chapter 10 Review. So if you just click that, then this is it here. It's all one PDF. So why don't I do just a couple of the first one's on L'Hopital's rule, and then I'll get you guys to do those. So I'll take kind of like a 10-minute sort of pause while you guys do some work. And then I'll interrupt you, and then I'll do one of these questions using the graph, and then you guys can do the rest. Maybe that's another 5 minutes, and so on and so forth. And we'll just kind of see how many of these we can get through. And look at this one. Question 5 is about a flu pandemic. Isn't that funny? Yeah. Okay. So yeah, let's start off with I don't know. Do we want to do? Why don't I do like some of the even ones, and you guys can do some of the odd ones. So I'll start off with number 2. So number 2, we've got that the limit as x approaches 0 of x minus sine of x over x cubed. Okay, so so this one, So, I mean, my guess is that we're going to be using L'Hopital's rule here. So when x approaches 0, we are going to have 0 minus 0 over 0, so that's 0 over 0. So this is definitely a 0 over 0 indeterminate form. So we can use L'Hopital's rule. So, and I'm just going to write LH. And that is where we just take the derivative of the numerator and the derivative of the denominator, and then see if it's any easier to take the limit. So in this case, the limit of x is 1, and the limit of sine of x is cos of x. So we've got 1 minus cos of x, and the the derivative of x cubed is 3x squared. Oh, and I forgot to actually write the limit again. Yep, I know. So this is the limit as x approaches 0. And let's see if this is any different. So cos of 0 is, what is that, 1? So we've got 1 minus 1, which is 0. So we have a 0 over 0 indeterminate form. So we can use L'Hopital's rule again. And we have that using L'Hopital's rule, we get that the limit as x approaches 0 of, okay, well let's do this one. So the derivative of 1 is just 0, and the derivative of negative cos x is going to be, well, negative sine of x, so positive sine of x. And then the derivative of 3x squared is going to be 6x. And it looks like this is still going to 0 over 0, right? So we got 0 over 0, but you can kind of see where this is going. Like, I'm hoping that what you can see is that there's a bit of a pattern here, right? Like we kind of have this sort of cyclic thing happening on the numerator. Like we're kind of going from sine to cos to sine to cos, and that's never going to go away. But when you look at the denominator, we've got a 3 and then a 2 and then now a 1. Hopefully that will kind of make some things a little bit easier to handle. So we'll use L'Hopital's rule again. And we get that the limit as x approaches 0 of, well, the derivative of sine of x is cos of x, and the derivative of 6x is 6. And I think that we can actually evaluate this limit now. So cos of 0 is 1 rather, and so that gives us 1 over 6. So that's not too bad. Okay, why don't I do one more, and then I'll get you guys to try the odd ones out, and then we'll leave a couple of the other ones just to. Yep. One over 0. Well, then you cannot use L'Hopital's rule. So you would do whatever you would do in. Like you would just evaluate that limit. So maybe you could factor out some kind of factor in the denominator that's giving you 0, and you can kind of see what's going on there. That probably, if you have 1 over 0, it probably means that either the limit does not exist or the limit is tending towards either positive or negative infinity. So you probably have some kind of asymptote at that point. So you need to think about the nature of that limit. Does that make sense? Yeah, okay. Because like the whole idea of these limits is that when you have a 0 over 0, it pretty much means that you've got like a common factor of like of x or something on the numerator and the denominator that you can sort of factor out and cancel. But when you have 1 over 0, there's probably not any common factors. So you have to just sort of think about the nature of that limit. Take the limit from the left, the limit from the right, see if they're equal. If they are equal, then it's probably tending towards positive infinity or negative infinity. And if the limit is not equal, then it means that the limit does not exist. Like what I meant to say is, if the limit from the left is not equal to the limit coming from the right, then the limit does not exist. So. Well, maybe intuitive was the wrong word. Easy. Like it simplifies things. Like, so if I have one function over another function and I get 0 over 0, then yeah, just take the derivative of each one. It just seems like something that you would do in calculus, you know? Like, there's certain things in math that we kind of like, we all sort of wish was true, right? Like, we all wish, yeah, like we all, I think that we all sort of at one point in our lives thought that this was a squared plus b squared, right? But it obviously it's not. But guess what? There's an area of math where this is true. So you know, do you know what I mean? Like, there's, if a and b are 0, yeah, it also works in certain algebraic fields. So you know, it just taking like L'Hopital's rule, it seems like one of those things that a first-year calculus student would sort of imagine up on their own and be like, oh, well, I bet you could just take the derivative of the numerator and then the derivative of the denominator and see what happens, you know? It just seems like one of those things that you would do. Exactly, yeah. It's like canceling out dx's, absolutely. Yeah, right? We all know that d by dx is the same thing as 1 over x, right? Because the d's cancel. So, it's simple as that. Calculus is easy. Yeah, I think what I was saying, what I meant to say, if I ever said that L'Hopital's rule was intuitive, I think what I meant to say was just that it seems like something that would happen in calculus. Even though it's not really something that is very easy to prove, it seems very calculus-y. Like, oh, you take a limit, the limit does not play nicely, you get an indeterminate form, so you take a couple derivatives and then take the limit again. It just seems like something that you would do. Okay, anyway, let's do a different question. Do we want to do number 6? We could do number 6, or we could do, want to do 8? Okay, so we got some natural logs. So okay, let's try number 8. So we've got the limit as x goes to positive infinity. Okay, so I've got the limit as x goes to positive infinity. I'm just going to write infinity instead of the plus infinity. And I've got x plus ln of x over x times ln of x. Okay, so this looks like, okay, so as x goes to infinity, well, obviously x goes to infinity. Ln of x also goes to infinity. Okay, so that's something. And then over here in the denominator, I've got x times ln of x, so this is going to be infinity times infinity. So I've got infinity, plus infinity, all over infinity. So we've basically got 2 times infinity over infinity, or in other words, we've got 2, right? Partial fractions. By the way, the last thing that I wrote was a joke. Don't do that. Could you use partial fractions? Yeah, the answer is 2. I mean, maybe it is. If it is, it's not because infinity plus infinity, right? Exactly. Yeah, so this is 2 times infinity over infinity. Okay, perfect. I think yeah, we're good. I think that we can kind of just take the early AP Calc exam. Yeah, so let's try this. So you want to use partial fractions? Okay. So you're saying, okay, so then you want to say that this is, those cancel and then these cancel. So then, and I forgot the limit as x goes to infinity. Okay, so yeah, I mean, here we get 1 over ln of x plus 1 over x, and then the limit. Oh my gosh, limit as x goes to positive infinity. Yeah, so absolutely, if you want to do it this way, that's fine. So this would be 0 plus 0. So this would be 0. Yeah. So yeah, I think that right at the very top of the question here, it says, if there is a more elementary method, use it. So yeah. True. Yeah. So I mean, the thing about limits, and this is true of a lot of areas in calculus, is that there's so many different methods of solving something. So whichever one is the most straightforward, just stick with that, right? So if you see L'Hopital's rule, then use L'Hopital's rule. But if you want to turn something into just two partial fractions, then absolutely do that too. Whatever floats your boat. But I think it's your turn to try some of these. So I'll leave this up on the screen. But if you want your own copy, they're on the website, just under Chapter 10 review. And then the solutions are here as well. So if you want to take a look at the solutions, you can do that as well. Which one is in? We did 8 and we got 0. So looks like we did it right. So yeah, give those a shot. I'm gonna put a little timer on for let's say 8 minutes, and we'll see how far we get. Yeah, what's up? Mm-hmm. If L'Hopital's rule applies, absolutely. But don't just take a look at a derivative or a limit and be like, okay, limit, I got to use L'Hopital's rule, even though it doesn't evaluate to like 0 over 0 or infinity, right? Like, yeah, yeah, exactly. Don't do that. Even though the derivative would actually work in that case. But yeah, so don't okay, I guess also if you're watching on YouTube, the question was if it says to use L'Hopital's rule, but then there's or any other method you want, should you use L'Hopital's rule or can you use any method you want? And my answer is to first of all make sure that L'Hopital's rule applies. You can't use L'Hopital's rule if the limit does not tend towards 0 over 0 or infinity over infinity. Also, we've seen that 1 to the power of infinity, that usually constitutes the use of L'Hopital's rule, but you have to use some logarithms to sort of make it work. And in which case you'll probably get some kind of exponential function as your limit. Anyway, yeah, give these ones a shot. And I'll set the timer now, and in 8 minutes we'll move on. And if at any point you're stuck, just say something in Discord or YouTube, and I'll address your question. Yeah, you could write it as a power series. But then you'll get like e to the 3x. Absolutely.
Oh, I see. Okay, that's dumb though.
Yeah, what's up? No. Only if you bring your microphone with you. Just kidding. No, I'm just kidding. Please don't do that. And you don't have to ask to use the washroom. Yeah, I got that. It's not a good time to have your internet cut out. Which one, number 7? Okay. Think of like pi times x to the minus 1. Okay. Yeah, so if there's a more elementary method, then use it. And that only works when x is tending towards infinity, right? Sure, yeah, absolutely that's a method. So it says, use L'Hopital's rule when appropriate. Like, if there's another method that you want to use, then use it. It's okay. Yeah, like you could, like if we were just going to normally evaluate this limit without L'Hopital's rule, then yeah, you would probably do something like 1 over 1 over root x times 1 over root x, right? And then these would cancel, and then you'd have 1 over root x plus 2 times x over root x. So this would be, this would tend towards 0, and then this would tend towards, well, this is actually root x, and this would tend towards infinity. So yeah, you would get infinity. Yeah, so not all of these you need L'Hopital's rule. Absolutely. The whole purpose of these questions is to recognize that sometimes you use L'Hopital's rule, Because L'Hopital's rule basically just allows you to evaluate some limits that you would have had a very hard time evaluating previously, but now it's quite simple. But some of them, you don't have to use L'Hopital's rule if you don't want to. Yeah. Yeah. For number 6, what I did is I multiplied the numerator and the denominator by 1 over root x. Right? So then these would cancel out. So then this is the same thing as the limit as x approaches infinity of 1 over root x plus 2 times root x. Because x over root x is just root x, right? So then as you take this limit, this tends towards 0, and then this tends towards infinity. So we get something that looks like 0 plus infinity, which is infinity. So the moral of the story is that we didn't use L'Hopital's rule there. You could have if you wanted, but you really didn't need to. Okay, done the time. Okay, let's do some more questions. I think next up is, these are more like limit style questions. Let's not do 9 to 12. Or at least I don't want to do them for you because I don't think you really need that. Let's do number 13. Which one of these is improper integral? Let's think about it. Okay, what about A? Is A an improper integral? Let's think about it. So, I mean, certainly the endpoints aren't going to positive or negative infinity. So we can't really just use that as a quick recognition of improper integrals. So really, like, and none of these have endpoints at positive or negative infinity. So it's not going to be because of that. So it's going to be, I think we call those type 1 improper integrals, where the endpoints lead to some undefined portion of the integrand. So when x is equal to 0, we don't have a problem, that's fine. And when x is equal to 2, we also don't have a problem. So I think we're fine on that front. So we don't have to take any limits. So not A. And then what about B? So when B is equal to, when x is equal to positive 1, we have 1 squared, so we got a half, that's fine. And we got negative 1 as well. Negative 1 squared is positive 1, so it's not this one. C, maybe... Yeah, that's a good point. Yeah, because there could be a point in here. So yeah, instead of it could diverge, but it could also converge as well. So yeah, so this means 1 dx. So yeah, that's another good point. Really, I mean, I guess what we should really be looking at is the domain. So let's think about the domain. So in this case, the bad part is when the radicand, like the inside of the radical, is negative. So that, or 0, yeah. So the radicand has to be greater than 0, or in other words, x plus 1 must be greater than 0, or x must be greater than negative 1, and it certainly is in this case, so it's not that. Over here, it doesn't look like there's, like, I think that the domain is just the real numbers here. X can be anything because x squared is always going to be positive, and then in addition to that, we're adding 1 to it. So there's no way that we could make this 0, so that's good. here's where we might run into some problems. We've got 1 minus x squared. So whenever if x is equal to plus or minus 1, we get, well, I guess in this case, 1 over 0, which is undefined. So, and it looks like we actually do pass through this point, through this point in our range here. So, yeah, I believe it would be this one, which probably means that we don't have to check D, but we may as well since we're here. So let's think about where cos squared of x could be 0. So if cos squared of x is equal to 0, well, that means that cos, I guess just cos of x would have to be equal to 0. And then that happens on every once in a while, right? So it happens when pi, x is equal to pi over 2 plus k times pi for any integer k. So doesn't look like that happens in this interval because we're going from 0 to pi over 3. So there's no integer multiples of k, or sorry, of pi over 2. So yeah, I think we're good. So yeah, that's that one. Is that okay? Do you guys understand like what I did there? Really, all I was doing was just looking at the range of the integral, like all of the points between these endpoints, and making sure that they didn't interfere with the domain of the integrand. So. Okay, great. Just gonna make sure no one's chatting in the Discord because now I can't see Discord. Okay. Okay. All right. Let's see. I think we can probably squeeze in one more question, and then I'll post the test. Okay, so so between these ones, we're going to either show that the improper fraction, or sorry, not improper fraction, the improper integral, that should say integral, converges and find its value, or show that it diverges. Okay, great. I think we've got enough time for just one of these. So let's see here. Let's do number 14. Okay, so we've got this integral. We're going from 0 to 2 of 1 over the square root, or the cube root rather, of x minus 1 dx. Okay, so let's see where the problem is. So here we really don't want x to be equal to, what is it, 1? When x equals 1, then the cube root of 1 minus 1 is 0, so we would get 1 over 0. And it looks like we pass right through that point. It's right in the middle. So what we're going to do is we're going to split this up. We're going to say that this is equal to the integral from 0 to 1 of 1 over the cube root of x minus 1 dx plus the integral from 1 to 2 of 1 over the cube root of x minus 1 dx. Okay, and we still have a problem here. Like, it's not like we've just solved it. At these endpoints here, we have an undefined value, so we're going to have to take a limit. So I'm going to say that this is the limit as, let's use the letter t, and sometimes I just have to draw a graph. So I'm just going to pretend that my graph looks something like this, and I mean, I don't think it does. I think it actually looks something more like this, if I had to guess. And let's see here. So here from this portion, I'm going from 0 to 1, and I'm attacking it from the left, right? So, so this is going to go, this is the limit as t approaches 1 from the left of the integral from 0 to t of 1 over the cube root of x minus 1 dx. And then similarly, let's use a different variable. Let's call this one the limit as, how about s? I'll try not to make it look like a 5. As s goes to 1 from the right of s to 2 cube root of x minus 1 dx. Okay, so this looks good so far. Now let's find the antiderivative of this. So I don't think I really have to do a u substitution because the derivative of x minus 1 is just 1, so that's nice. So this is going to be, this is kind of like x minus 1 to the third. That's kind of how I'm thinking about this. So what I'll do is I'll oh yeah. Negative 1/3. Thank you. Got a minus. So I'm going to increase this by 1, which would give me 2/3, and I'm going to multiply that by the reciprocal. So this is, well, let's not forget the limit. So this is limit as t approaches 1 from the left of x minus 1 time to the power of 2/3, and then all times the reciprocal of that, which is 3 over 2. And we're going from t, or 0 to t. And then we're going to have the same thing. So the limit as s approaches 1 from the right of, well, I don't have to do all that work again. I can just copy it out. X minus 1 from, oh, and that's 2/3. Yep, oops. 2/3 from t, oh, and not t, 2 on the top and s on the bottom. Okay, so let's see what this looks like. I have, okay, so I'm going to keep the limit. T approaches 1 from the left of, let's see, 3 over 2 times, and this time it's t minus 1 to the 2/3 minus 3 over 2 times, what is that? 0 minus 1 to the 2/3. I guess it would have been helpful if I'd factored out that 3/2. I guess it's not too late for that. Why don't I go ahead and do that? I'm going to factor out all of these 2/3 so that way it looks a little bit more nice. So I've got 3/2 times all of this. And then here I've got plus, oh yeah, and then I've got another limit. Limit as s goes to 1 from the right of, okay, s, no, yeah, no, 2 minus 1, 2/3, minus s minus 1 to the 2/3. And let's see what we get here. And then I've got this big set of brackets out here, like this. Okay. And when t goes to 1 from the left, well, let's just see what happens here. T goes to 1 from the left. I'm going to get, well, I get 0 to the 2/3. And it doesn't matter because my denominator here is odd. So even if I was taking it into the negative land, I wouldn't have any problem at all. This is just 0, right? This is just 1 minus 1, which is 0 to the 2/3. So here I get, so this is going to be 0 minus, this is going to be negative 1 to the 2/3. So that's negative 1 to the 2/3, and we can clean that up in just a second, plus, and then over here, the limit is, well, I guess I don't have to take the limit quite yet. I've got 2 minus 1 to the 2/3, so that's another 1. to the 2/3 minus, well, s is going to 1, and again, it doesn't matter which direction because the denominator of this exponent is odd, so I'm allowed to take negatives. So this would be 0 to the 2/3. And then this is just all sort of cleaning it up. This is going to end up being positive 1 because we're going to square it. So this is positive 1. We're subtracting them. Everything else is 0. So this is 3/2 times 0, which is 0. So there you have it. Oh, wow. You have a test in 10 minutes? Oh, nice. 2 tests today. Yahoo. Okay, so I'll post your calculus test on the website, and let's see if we can have that done by Monday. If you're having any issues with it, let me know. What was that, Nick? We're gonna do both. The only reason I want to have a Google Classroom is so that I can give you your mark back. Otherwise, I wouldn't be able to give you your mark. The Google form will be on my website, and I have everyone's email address, so I'm just going to add you using your school division email address. So you'll just, do you guys already have Google Classroom like on your phone, or like you're connected? So you'll get a notification being like, Mr. Bennett added you into his classroom, something like that. So like when I added my grade 9s, like almost immediately half the class was accepted into the classroom. So I'm assuming that you get some kind of notification. Anyway, I'll let you go because it sounds like you got another test to worry about. Good luck with that. Don't hesitate to reach out over the March break. Before you go, I just want to say that I'm deeply impressed by how everyone has been sort of coping through all of this and keeping up with all of the work. I know that it's really, really challenging to keep up with all of this when you're not actually leaving your house, and your sleep schedule is certainly affected by this. So keep up the good work. I hope that you actually do get a break over March break. But if not, take care of yourself. And if you ever want to reach out, just say hi or anything like that, or a question about calculus, hit me up on Discord or Instagram or whatever you like. Anyway, I'm gonna let you go, and I'll talk to you later. Bye bye.